Hi YouTubers, Dave once again out in Western Pennsylvania, USA. And in this short video, I am showing you a dry circuit. And I've defined that in prior videos. A dry circuit, by my definition, is a section of graphite. Here you can see graphite felt with some current collectors attached. And it's in series with two commercial supercaps, so I can bring the potential up and see if DES solvents, deep eutectic solvents, with electrolytes like lithium bromide, that would be a wet circuit, can be brought up to 3.9, 4.1 volts maximum. Now, of course, with series supercaps, each of these is rated, I purchased them from Amazon, they're relatively new. They're rated at 2.8 volts, 100 farads capacitance. And I did a quick approximation, and definitely the capacitance is in the 90s. That was just a quick check. Time interval. I would not bring the supercaps up higher than that, even though in principle I can go to 2 times 2.8 or 5.6 volts. I don't go near it because I don't have any resistors set up here in parallel for each to balance the potentials. So I don't need to go up to 5.6 volts. I'm staying well below that. I'm going to about 4.2 volts with a constant voltage charge, and then trickle current down to, let's see, 0.15 amps. So be very careful not to go up to the full potential in series with the supercaps. It's better to stay well below them in case imbalance occurs. Please be very careful. So they're in series. I've run them separately and as a series setup in a circuit with my electronic load device, ZKE Tech. Boy, I noticed they're down to about $115 each at Amazon. And we have about 10 at school. I'm in my office right now. Make sure if you want to do series, if you want to do cycle series, cycles, charge, discharge, make sure you get model EBC-A10H. A20H will only do single tests. And you can see, here's my input of values. I'm charging up at constant voltage, 750 milliamps. And I bring it up to 4.2 volts in series with the two supercaps. And then I use a trickle charge and I cut it off at 0.15 amps. I give it a wait period of 1 minute, and then a discharge at constant current. And I bring it down at 500 milliamps. And then I cut off at 0.30 volts. Then wait a minute, and I'm doing 100 cycles. And right now, very interesting, I've seen this before. It'll start off with a Coulombic ratio, and I estimate that by looking at the capacities, milliamp hours for both charge and discharge. You can see they're pretty steady. They start out about 0.024. And then at about cycle number 15, it goes down from 0.024 down to about 0.023. And you can see that when you hit cycle 31 there, it's starting to go up a tiny bit again, 0.024. But I'm looking at the ratios, and I want 1-to-1, and I'm getting it, which means I'm not losing energy as thermal, as heat. Now, this is only a dry run. There is no DES electrolyte solution applied. I just want to run it and see the mass of the graphite before and after. I'll post the dimensions of the graphite. That's very important, of course. And I can tell you that when I bring it up to 4.2 volts to charge, as soon as it hits 0.15, the cutoff, 0.15 amps, it drops to 3.80 volts. It drops off to 3.80 volts, and that's fine for this test I'm doing right now. And then when I close the circuit and start my study, there'll be a drop to 2.5 volts due to the resistance in the supercaps and, of course, the graphite. But then I'm running it from 2.5 volts down to 0.3 volts. So that's fine for me because the commercial supercaps I use are at 2.7 volts. And if I can get this to run and start off at 4.2 and then a drop to 3.80 and then with a run down to 2.5 volts, that's okay for the testing I'm doing. And I'll cautiously bring it up to about 4.4 volts open circuit. But I'm not going to go much above that. And what I want to do is test different DES electrolytes. I'll seal it off in a plastic bag when I do that. And I want to run 500 cycles and see how the DES electrolyte and the graphite electrode behave, how they perform. I'd like to look at the separate components. And when I work with my undergraduate students, I'll be retiring after 40 plus years with my university in June. I'll be continuing my research. But I think for students that are undergrads or home researchers, you want to start very simple, get a feel for the components before we actually run long and very narrow graphite electrodes. This is felt. I also use yarn. And I can show you over here on Amazon, I pick up these C dummies. And down the road then, I will roll up to increase surface area and thus hopefully get decent capacitance. And students then will roll them up and then they'll be able to test something that looks somewhat professional. But this is the way I'd like to bring them along. And a growing number of students are interested in energy storage, and they should be. And for home researchers, I don't want them excluded. This is something for them to work on, for some of you guys to work on. Just be very careful not to overload those caps, supercaps. And that's what we have right now. When this is done, this run, I'll put all the data there so you can examine those Coulombic ratios by comparing the capacities for each individual cycle. Thanks for watching. I'll keep you posted. Bye for now.